Okay, we're going to continue our discussion of solving systems of equations, this time looking at another method. This is called solve by elimination, or you might see it in your book as solve by addition. And the point of it is I'm going to take my two systems and I'm going to add them to eliminate one of the variables. So that's why you might see it written two different ways. So we are going to jump right in and we're going to look at this first set of equations, and I'm going to scroll down and I'm going to write the example one more time down here. So I say, okay, let's see if we can solve this system. 2x plus 3y is equal to 14. And my second one is negative 3x plus y is equal to 23. The point of this is I need to choose one of my variables that I'm going to eliminate. And in order to eliminate it, I'm going to add. I'm going to add the two equations together so that I can eliminate one of the variables. I'm going to choose to try and eliminate my y's. So I'm going to be looking at the coefficient here in front of my y's. I have a 3 and a 1. So I need to think to myself, how do I add these two together to get 0? 3 plus what gives me 0? Well, I should hopefully be saying to myself that 3 plus a negative 3 gives me a 0. And that's how I know what to multiply my second equation by. I'm going to multiply my second equation by a negative 3. When I do that, I can rewrite this equation as 9x minus 3y is equal to 23. So I just rewrote my second equation with a multiple of 3 and made it really just a bigger equation. But the reason I did that is because when I add these two equations together, the blue equation and the green equation, and I add straight down, 2x plus 9x is 11x, but 3y minus 3y is 0. And, oops, this should be a negative 20, it shouldn't be negative 23, it should actually be negative 69. And I see that when I add 14 and negative 69, I should get negative 55. Well, I just want to try to solve for x from here, so I divide both sides by 11, and I see that x is equal to negative 5. And I want to, so now that I have found out what x is equal to, I need to substitute x into one of my original equations to find y. So we're going to choose, let's choose 2 times negative 5. We're going to choose the first equation, plus 3y is equal to 14. So negative 10 plus 3y is equal to 14. Add 10 to both sides. 3y is equal to 24, so y is equal to 8. I discovered that the solution to this set of equations was negative 5, 8. And that's how you solve a system of equations by elimination. But you might be asking yourself, how do I know which variable I want to eliminate? Do I choose the y's or do I choose the x's? So let's rework this set of systems, this time choosing the opposite, and I'll show you what I mean. This time we're going to work the same equations. Let's say 2x plus 3y is equal to 14. Negative 3x plus y is equal to 23. Well, before I looked at the coefficients of my y's to try to eliminate the y's. This time I'm going to look at the coefficients in front of my x's. I have 2 and a 3. So what we can do is we can actually multiply the first equation by the second equation's coefficient of 3, and we can multiply the second equation by the first equation's coefficient of 2. And watch what happens. When I do that and I multiply the first equation by 3, I get 6x plus 9y is equal to 42. And the second equation, when I multiply by a 2, gives me negative 6x plus 2y is equal to 46. The reason I chose a 3 and a 2 was directly because of the coefficients in front of the x. I set my mind out to say I was going to get rid of the x's, so I multiplied them in opposite order. The 2 is the coefficient of the x in the first equation, so I multiplied it into the second equation, and I did the opposite. I did it kind of reversed for the other one. The 3 is the coefficient of the second equation, so I multiply it by the first. Now you might be asking what happened to that negative sign. I looked at these two equations and I knew that I didn't have to multiply by a negative anything, because just by multiplying by 3 and a 2 gave me my opposite sign I needed, since the negative sign was already here. So if I want to add these two equations together, my x's are now eliminated and I get 11y is equal to 88. So y is equal to 8. And I'm going to substitute my y back into one of my original equations, not one of the equations I multiplied by. So let's take the first equation. 2x plus 3 times 8 is equal to 14. 2x plus 24 is equal to 14. So 2x is equal to negative 10. So x is equal to a negative 5. And that is the same solution that I came up with just a minute ago, eliminating the y's. Only this time I eliminated the x's. So it doesn't matter which you choose, as long as you just can choose to eliminate one of them. Now, let's practice another one of these examples. Let's practice the second example. X minus 3y equals 4 and negative 2x plus 6y equals 3. So let's find us a piece of blank spot here. I think we can add something in here. Add just a little bit more. And we will go ahead and we will work the second set of problems, the second set of systems, and we'll solve them. So if we have x minus 3y is equal to 4 and negative 2x plus 6y equals 3. So I want to think to myself, which variable do I want to eliminate? Let's just eliminate the x's. So I'm looking here at my coefficients. I have a 1 in the first equation and I have a negative 2 in the second equation. So if I want to eliminate my x's, I can multiply the first equation by a positive 2, because a positive 2x plus a negative 2x eliminates that value. So let's rewrite this over here. Let's multiply 3 by 2 and we get 2x minus 6y equals 4. And we'll rewrite the second equation. Negative 2x plus 6y is equal to 3. And it's not, I need to change that. It's not 2x minus 6y equals 4, it's 2x minus 6y is equal to 8. Second time I've done that. Now we want to add straight down. When I add 2x plus a negative 2x, I get 0. But when I add negative 6y plus 6y, I also get 0, and that's okay. 8 plus 3 is 11. So now I need to stop and think, does 0 equal 11? Is that a true statement? Well, it's not. It's a false statement. And therefore, I have no solution. So this is the third example of our possible solutions for systems of equations. We can have an ordered pair, which gives us one solution. We can have a true statement, which gives us infinite solutions, and we can have a false statement, which gives us no solutions. And this is our third method of solving systems of equations.